Assalamu alaikum. In this video, we are going to learn how to find the lower and upper bound of a value. So the width of a house is 70 meters to the nearest 10 meters. We need to find the lower and upper bound of the width. So first of all, the lower bound is the minimum value that will be taken before the number is rounded, and the upper bound is the maximum value that the number can take before it is rounded. So in this case, the rounded value is 70. And to find the lower bound, which I'm abbreviating as LB, you will subtract the half of 10. This you're rounding to the nearest 10 meters. So you will subtract the half of 10 to find the lower bound. So this will be 70 minus 5, which is 65. The lower bound is 65. The upper bound will be 70 plus 10 over 2. Again, we are rounding to the nearest 10 meters. So the upper bound will be 70 plus 5, which is 75. Now, one point that you should understand is that the value can be equal to 65, it can be equal to the lower bound, but it cannot be equal to the upper bound. Because if it is equal to the upper bound, 75 is rounded to 80 to the nearest 10 meters. So this is how we write it as an inequality. If you want to give your answer as an inequality, this is how you will write. Now, we look at another example. The speed of a plane is 1200 kilometers to the nearest 100. What is the lower and upper bound for the speed? So again, the rounded value plus minus 100 over 2. So this is what you need to do to find the lower and upper bound. The plus minus 100 over 2 is the degree of accuracy. So the lower bound is 1200 minus lower bound is 1200 minus 100 over 2, which is 1150. The upper bound is 1200 plus 100 over 2, which is 1250. Again, the speed can be equal to 1150, but it cannot equal 1250, because if it's equal to 1250, then 1250 rounded to the nearest 100 is 1300. So this is how we find the lower and upper bound. Another example, the population of a town is 80,000 to the nearest 1000. We need to find the lower and upper bound. Again, the degree of accuracy will be plus minus 1000 over 2. Rounded value is 80,000. From this, you will first subtract 500 and get the lower bound, and then you can add 500 to get the upper bound. This is another example. You can take a look at it. Same concept. You see that the rounded value is 84,000 and you're rounding to the nearest 1000. The degree of accuracy will be 1000 over 2. If you're rounding to the nearest inch, so this is the height of a chair is 24 inches to the nearest inch. The lower bound in this case will be the rounded value is 24 minus half. So the lower bound is 23.5 inches. And the upper bound will be 24 plus 1 over 2, which is 24.5 inches. And again, the height can be equal to 23.5, but it can not be equal to 24.5. This time you're rounding to the nearest tenths. Tenths in place value is 0.10. So the lower bound will be 2.9 minus 0.1 over 2, which comes out to be 2.85 centimeters. The upper bound will be 2.9 plus 0.1 over 2, which is 2.95. Again, as an inequality, I will write it as 2.85 is less than equal to r is less than 2.95 centimeters. So hope this clarifies the concept of lower and upper bound. Please like the video and subscribe to the channel. Allah Hafiz.